this exercise is to solve variable x when the x is on the power. So we have exponentials and we solve like the power. Okay, we can solve first by logs. Definitely we can solve it by log, but we don't want to use log all the time. So there are some easy case. I can directly equalize both sides with the same base, and we can easily equalize the power and solve for x. Okay, for example, for this question, 4 to the power of x and 256. Okay, let's have a look at 256. If I divide by a 4, that gives me 64. If I divide another 4, that will give me 16. So 16 contains another 4. So 4 to the power of x should equals to 4 to the power of 4. Okay, x then will be equal to 4. Okay, x equals to 4. We are aiming for the same base. We're trying to make things into the same base, and then we can equalize the power. But means both sides are equal. Okay, if they have the same base, only if the powers are the same, then the two numbers can be the same. Okay, the next one is 5 and 25 as the base. I can say 5 to the power of 2x minus 4 equals to 5 to the power of 2, then to the power of minus x plus 2. Okay, this side is 5 2x minus 4 equals to 5 minus 2x plus 4. Okay, the power can be times together. So 2x minus 4 will equal to 2 minus 2x plus 4. Okay, 4x will equal to 8. X will be 2. Okay, 64. Okay, 2 and 1 on 64. So 64 is 8 times 8. Okay, 8 is 2 to the power of 3. 2 to the power of 3. So 64 is actually 2 to the power of 6. Okay, 2 to the power of 6. Then 2 to the power of minus 1, to the power of minus 3x equals to 2 to the power of negative 6. Okay, 2 to the power of negative 6. Minus 3x will equal to minus 6. X will be 2. Okay, everything we're trying to do is making to the same base. Okay, if we can make it to the same base, then it will be easy to solve by this way. Okay, it's easy to solve by this way. Okay, that's the first question. And let's have a look at the second question. Okay, this is a like typical type. This is a very important question. I see a lot of practice exam, a lot of the actual VCAP papers, they all have this type of question. Okay, it's not only this type. There will be like there's some type of this. We use the same method, okay? We use the same method, but the equation doesn't need to look like this exactly. I'll show you more examples later, but let's have a look at what we can do to this one. This one is like changing variables. Okay, I want to change x to another variable. Why I want to change it? Because this equation is not really familiar to me to solve. So what I can write is 9 is 3 to the power of 2x, okay? And this is 12 times 3 to the power of x minus 27. Okay, you have 3 to the power of 2x and you have 3 to the power of x. So what we'll have is 3 to the power of x, then to the power of 2. Okay, make it to the power of x first and then change it to the power of 2. That equals to 12 times 3 to the power of x minus 27. Okay, I'll say let 3 to the power of x be capital A, or capital A is 3 to the power of x. And that is a to the power of 2. This side is 12 times by a and minus 27. So a squared minus 12a plus 27 equals to 0. I can solve quadratic. Okay, I can solve quadratic easily. So a minus 3 times a minus 9 equal to 0. So a will be 3 or a will be 9. Don't forget you are solving for x, you're not solving for a. A is what you give. So you have 3x equals to 3 or 3x equals to 9. Therefore x will be 1 or x will be 2. Okay, that's how we solve this type of question. Just write another question here. Right. Well, I'll just make another question for you, okay? 3x equals to 3 root x plus 6. Okay. A similar type of question will be this. Okay, a similar type of question will be this. It's not necessary to be only exponential. Okay, not necessarily only have exponential inside. I can have linear and square root. Okay, I can have linear and square root. The most important thing is you should realize, okay, for this question, the term include the power x. Okay, the relationship between them is that is square of the other one. Okay, one is the square of the other one. And let's have a look at this equation. The power x and the square root x. Okay, x is the square of square root x, right? X is square of square root x. So when you see two variables with this relationship, you will think about using this method. Change the lower one, become capital A. Okay, change the lower one, become capital A. That's how you can recognize this type of question and how you can set up your variables. Okay, so you have two places, you have your variables, and one term contain the variable will be square of the other term contain the variables. And if that's the case, you will set up the lower one, okay, the smaller one, to be the capital A, and you will result in a quadratic. Okay, you will result in a quadratic. Therefore, what I can say is 3 root x to the power of 2 equals to 3 root x plus 6. And let's say b. Let b be square root x. So 3a squared equals to 3a plus 6. Okay, 3a squared minus 3a minus 6 will equal to 0. Okay, it's a quadratic. I can solve quadratic easily. So what I can have is 1 and 3. 6 can have 2 and 3. I want a minus that. So minus 6 plus 3 equals to minus 3. What I can have is a minus 2, 3a plus 3 equal to 0. A can be 2 or a can be minus 1. Which means the square root x can be 2 or square root x can be negative 1. So what x will be? I'm not going to do the last step. What's the x will be? Square root x equals to 2, what is x? 4, okay, 4. Square it. Square root x is -1, what is x? No solution. Nothing square root can be -1, okay? Square root x must give you a positive number. Square root x cannot be -1 for sure, okay? It doesn't matter what case. So no solution on this side. So you will only have one solution, which is x equals to 4. Okay, so no solution on this term. Any questions? Any questions? Okay, if there's no questions, let's look at next page. Logarithms. Okay, logarithms. Okay, we start to learn log. Okay, exponential and log always connect together. Okay, we always change log functions back to exponential functions to solve for it. For log, there are only those laws you can use, okay, here. Okay, that's everything you can use for log. Log has their own law, okay, it's not really follow the plus minus law. It has the own law. You can't create any other methods, okay, you can't create any methods like to start with. Like, I'll show you example later, like that's something students think is correct, but it's not actually has this law, okay. So we'll have law 1 is when you have times inside, you can separate that as a plus. Okay, log AMN is log AM plus log AN. Similarly, if you have divisions inside, it will be log AM minus log AN. So there's a common mistake is when students see log A plus M inside, they say that's log AM times log AN. Okay, so that's not true. Okay, that's not true. We don't have this one. Okay, we don't have this one. So you must remember the rule for logs really clearly, and you can only use those methods to calculate logs. Okay, law 1 and law 2. So the proofs, like below, is not really required you to remember them, but if you want to have a look, and I'll just put it here for you to have a think about it. Okay, it's all coming from exponential. Okay, it's all coming from the exponential. Law number 3 is when you have a power in the bracket, you can drag the power into the front. Okay, you can drag the power into the front. And law number 4, again, law number 4, you can treat law number 4 as this nothing, okay? Because the -1 will be directly dragged into the front, become negative log AM. It's exactly the same of law 3. Okay, it doesn't really need law 4 there. Okay, there's no law 4. And we have some extension. Okay, we have some extension. So the extension thing is a to the power of log AM will equals to m. Remember when we do the, we try to derive 4 to the power of x. And we'll change 4 to log e to the power of log e4. And then the whole thing to the power of x in order to derive. Remember that we can't derive things with any base. I can only derive with nature base. So I need to change base 4 to a nature base first and then derive. Okay, that's the rule we use. Okay, that is the rule we use. A number equals to a to the power of log a and of that number m. Okay, so we need to remember that. That's extension. And law 5, we have log A1 equals to 0 and log AA equals to 1. Okay, I don't really need to explain this to you. Log A1 equals to 0 and log AA is 1. You can change it back to exponential and it will make sense. Okay, the really helpful thing is the change of base formula. Okay, change of base formula. Remember, we still use change of base formula when we're trying to derive log 4x. Okay, when we want to derive log 4x, we can't derive any base except nature base. So we use change of base to make it log ex and divide by log e4. Okay, and then we're trying to derive from that. So when we have log AB, I want to change it to another base C. That will be log CB divided by log CA. Okay, that equals to log CB divided by log CA. So that's change of base. Okay, that is change of base. I can change any base. Okay, I can change it to any base. Why we have the change of base formula is when like about 10 years ago, the calculator is not that powerful. They can't really directly calculate like log 48, something like that. They will have they install all the values to base E. Okay, they only remember base E values. So when you're trying to evaluate log 812, you will change it to log E12 and then divide by log E8. That's how we calculate different base. So the calculator at that time only remember all the values for log base E. So this like before is we use for that, but like today we learn it, like it can help us with a lot of calculations, okay? It's not really for that purpose anymore. So for example, I want to do derivatives for any base. So I need to change it to the base E and then derive. It's more like a tool. Okay. Use change of base to prove that log AB equals to 1 over log BA. Okay, I want to prove that log AB equals to 1 on log BA. Okay, let's say left hand side equals to log AB. Like why go to listen the exam assessor, like they give like a speech on the part 1 exam, how like well or how poor the student doing on each questions, and they mention a point like it's the notation of mathematical notations. Okay, they want you to write it correctly. So for example, log base EX, do not write log X. Okay, that will lose mark definitely. Okay, it should be log E, like the E should be here. It's not log X. Okay, so you can't have that. Someone just like read too quick, and that's wrong. Yep. You can write ln. Yeah, log. Okay, log EX is the same as ln X. Okay, ln X. Not really. But if you give enough, like where is the base and where is the X, and that's okay. Okay. So the correct notation is important. Do not just think about like, oh, they should understand what I'm writing. Yes, we understand, but we still give not marks for that question. Okay. So make sure you write correctly. Okay, let's do this. Log base AB. I want to, okay, how we can make this become that. Okay, have a look at what is the base on the right hand side. What's the base on the right hand side? B. Okay, so we want to use change of base to change this to base B. It doesn't say I can't change it to the same number. I can still change it to base B. So let's say that's log B over log BA. So what is log B? 1. So that is 1 on log BA. And that equals to right hand side. I have proved that. Okay, it's just a really easy change of base question. But like you should remember this relationship. Okay, log AB will be 1 over log BA. It will be the same. Okay, for this one, what's the base on the left hand side? Okay, a to the power of q. What is the base on right hand side? A. Okay, let's just change the base. Okay, left hand side will equals to log A bracket B to the power of P over log A to the power of Q. That is P times log A B over Q times log A. So log AA equals to 1, so here is 1. That is just P on Q log AB. Okay, that's how we prove that. And that equals to right hand side. Okay, so evaluate the following. So log 3, 81. That's log 3. 81 is 9 times 9. 9 is 3 to the power of 2. That's 3 to the power of 4. That is 4 times log 3, 3. Log 3, 3 is 1. That's just 4. That's just 4. Okay, I want you to do the questions. Okay, how many I want you to? Okay, I want to give you 5 minutes. Maybe 5 is too much. 3 minutes. Okay, let's do 2, 3, and 1 and 2. 4 questions. Okay, next 4. Number 2, number 3, number 1, and number 2. Do those 4 questions. Okay. 2 minutes is enough. Quickly do it. Just quickly do it. Do those 4 questions, okay? 2, 3, 1, and 2. Okay. So example 2 will be this one. Okay, -3. 127 can be written as 3 to the power of -3. Drag the -3 to the front. We have -3 log 3, 3, which is -3. Okay, this is nothing hard. And example 3, I just wondering if anyone have answer like that. Anyone's doing that? Hopefully not. Okay, hopefully not, because I have seen answers like that before. It seems like quite right, okay, at the beginning. It seems like, oh, okay, I have same base and I will just divide the number. But we don't have this rule. Okay, that's the thing I said. If you don't have this rule, you can't do by this way. Okay, you can't do by this way. So that is actually not correct. So what we should do is, that is log 3, 7 to the power of 2. That's 49. And log 3, that is 7 to the power of 3. Okay, 49 times another 7 is 343. Okay, 49 times by 7, 34. Okay, so it's 7 to the power of 3. So what I have is 2 times log 3, 7 divided by 3 times log 3, 7. On both top and the bottom, we have log 3, 7. So what we left is just 2 on 3. Okay, what we left is just 2 on 3. Okay, example 2. I'll first put the 2 back. Okay, I'll first put the 2 back. Okay, so put the 2 onto the power, put the 2 onto the power, plus is multiply and minus is division. Okay, plus is multiply and minus is division. So I will have 100 in the bracket. Okay, after the calculation, 9 times 16 divided by 36 over 25, we'll have 100. Log 10 100 will be 2. Okay, log 10 100 will be 2. So we'll have 2 here. Okay, last one. Last one will be take the power out, drag the power out, and both top and bottom include log 6x. Okay, we just delete log 6x, and we have 3 on 2 over a half. Okay, 3 on 2 over a half, and that is 3. Okay, that is 3. Okay, do we have any questions about this? Okay, if not, let's keep looking at example 3. Okay, for the first 3 examples are easy. Okay, this one will be x to the power 4 equals to 256. Okay, 256. I think I just work out 256 is somewhere 4 to the power 4. Okay, at the very beginning, that's 4 to the power 4. So x to the power 4 will be 4 to the power 4. Now they have the same power. If they want to be the same, then base needs to be equal as well. Okay, base needs to be the same. Next, log 5x equals to a half. So what x equals to? X equals to 5 to the power of half. And x will be root 5. Okay, x will be root 5. Log 2x equals to 4. Okay, 12 divided by 3, we have 4. And then x will be 2 to the power 4. X is 16. Okay, x is 16. So basically, if you want to change to log, we always think about exponential. Okay, we always think about exponential. We'll put things back to exponential and solve for it. Okay. Okay, important thing is the next two. Okay, the important one is the next two. Okay, log 2, 2x plus 1 minus log 2, x minus 1 equals to 4. What we'll have is log 2, bracket 2x plus 1 divided by x minus 1 equals to 4. And we'll have 2x plus 1 divided by x minus 1 equals to 2 to the power 4. 2 to the power 4 will be 16. Okay, 2 to the power 4 will be 16. So 2x plus 1 equals to 16x minus 16 times x minus 1 on both sides. Okay, times x minus 1 on both sides. 17 equals to 14x. So x will be 17 over 14. 17 over 14. That will be the answer. That's 2 to the power 4. Okay, that's not 4 to the power of 2, it's 2 to the power of 4. Okay. Next one. Next one will have log 3 x minus 1 times x plus 1 equals to 1. X minus 1 times x plus 1, that is 3 to the power of 1. X squared minus 1 equals to 3. X squared equals to 4. What x equals to? What x equals to? Well, just this case, what x equals to? Plus minus 2. You need to write plus minus 2 here. Okay. Do you think that's the correct answer? Why not? Which one is not the correct one? Okay. Check your domain. Okay, for logarithm questions, okay, solving logarithm equations, you need to check your domain. Because when you sub your answers back into this, that needs to be greater than 0. If that's smaller than 0, you don't have that answer. Okay, so you will reject x equals to minus 2. Answer is x equals to 2. When you put negative 2 minus 1 will give you negative 3. Okay, it's not fit this domain. You don't have minus 2. You only have 2. When you put 2 in, you have 2 minus 1, which is 1, is okay, and 2 plus 1 equals to 3, which is okay. So you always need to check your domain of your log equations, okay? It's very, very important. Most of the time, okay, say 60% of the questions in VCAP papers, they won't give you accept both answers. It's always reject one and accept one, okay? So needs to be careful with that point, okay? Otherwise lose 1 mark. But in this step, you need to write x equals to plus minus 2. You can't directly reject 1. Okay, so because that equation will give you x equals to plus minus 2, you will reject after you check it. You are not reject as the green circle step. Okay, you are not reject there. Okay. Last two, let's finish this. Okay, example 4. When you're trying to solve, okay, again, that's the exponential function. Okay, if that's an exponential function, I can't make both sides to have the same base. Then we'll think about using log. Okay, I can't make 2 and 11 to become the same base. Then we'll start to use log. Then x just equals to log 2, 11. Yeah, x just is log base 2, 11. And for this one, power is 2x minus 1. That is log 3, 28. You're solving for x. 2x is log 3, 28 plus 1. And x is log 3, 28 plus 1 over 2. Okay, so this is a really, for what we learned today is just purely solving questions, okay, solving equations. But the most important thing is these 2 questions, okay. The example 2 on this page, this method, you must know that, okay. This is an important example. The next one will be example 5 here, okay? Check your domains for logarithms when you solve for it. Those 2 questions are very likely to be on the VCAP exam. Okay, there's a lot of papers contain one of those 2 questions. So which is quite important. So you need to learn those two questions, okay? Okay, that's all for today.